This video is going to show you how to find the area of a composite shape. And a composite shape, the definition, is basically something that's made up of two or more shapes. And if you want to find the area of it, the best way to do it is break it up into smaller pieces that you're more familiar with. So this picture that's right here, they've drawn lines in the center, and that then created a square and then two triangles. So those three shapes would be easy to find the area of, and then like it says, we can add them together to get the full area of the composite shape. The first example we're going to look at is of a swimming pool, and it says Drew is staying at a hotel that has a swimming pool that looks like the picture next to it. He wants to find the area of the swimming pool at his hotel. So if I zoom in on just the picture of the swimming pool, it's going to look kind of like the blue figure that's already drawn there. But basically, we're going to take the outline of the swimming pool. This is not a normal shape that we just automatically have a formula for. But the way they have done it in the diagram is they took this section right here and they drew a line to divide it into two parts now that we can find the area of. Okay, that's out of the way. So once you get your two shapes from the diagram, we can identify what they are. We have a square and a rectangle on this one, and the reason I know this one is a square is because in the picture they labeled both of these as 10. And squares and rectangles are really easy to find the area of. We talked about this before, the formula for finding area of a rectangle or a square. Some people might like to say length times width. On 7th grade math chart, it is going to say BH. And we said that means base times height. So I'm going to erase that for a second so I have some space to do this. On the rectangle, I'm just going to do 12 times 6. That is 72. On the square, they have the same dimensions, so I'm just doing 10 times itself. 10 times 10 is 100. Then if you remember back to the previous slide, it said you should add your two shapes together to get the total composite area. And if we add, I'll do it at the top, 100 plus 72, that's going to give me a total of 172. Ooh, that is so messy. Okay, I'll just write the answer. 172. Then we always want to go back and use the units. This diagram is being measured in meters. So I want to put in M to show it's 172 meters. An area always means that you're finding out how many squares actually fit inside the entire shape. So the little symbol that we use for squared is a small 2. You can also say SQ, the words or the letters SQ if you wanted, but the little exponent of 2 might be faster for you. The next diagram looks like it's already been cut. It has a dotted line going down right here, so it's already separating it into two shapes for us. This is going to be really important in a minute when we are figuring out one of the shape's dimensions. It says the shape is not drawn to scale. So just because this area right here looks really big, it may not actually be larger than this space. Okay? I'm going to redraw the shape over by this box, but you do not have to. I'm just going to do it that way because it was in the first example, and maybe you can focus on each shape separately. If we go back and look at just the rectangle, the dimensions for the rectangle, I have 5 and 6. So I'm going to put that on my shape. 5 was the left side of the rectangle and 6 was the top of the rectangle. you have to be careful because this 14 is not only the rectangle, the 14 represents the entire length of the bottom of the composite shape. Okay, so the rectangle. I'm just going to go ahead and write this in, even though you guys know because we just said it. I have a rectangle. The way I find the area of a rectangle on the 7th grade math chart, it says you should do A equals BH. And we said that's base and height, or length and width. So real quick, 6 times 5 is 30. So then I could say that this space is equal to 30 units, 30 square centimeters. The second shape that I'm dealing with over here is our triangle. So I've redrawn it right here. When you look in this diagram, I don't see any numbers specifically by the triangle's sides. However, I can identify quickly this vertical dotted line. It's also part of the rectangle. So if you look on this side, this says 5. Well, if I shift it over, these lines are exactly the same length. So that means the triangle needs to also have 5 on its side. The part of the triangle that's missing that I need to figure out right now, though, is this little area right here. I don't have a single number for it. So what we're going to have to do is, if I take away the rectangle part, which we already said was 6, I'm going to take away all of this space. I don't want it anymore. The whole thing used to be 14, so I would do 14 minus, I took away the length of the rectangle, which was 6. So I'm going to do 14 minus 6, and that gives me 8. So actually, the base of the triangle is 8. Now this is where I was saying earlier, this says the shape is not drawn to scale, because if you take a look, this small little section of the triangle we figured out is 8. But then when you look at this really long area of the rectangle, it says 6. So that really doesn't make sense. So you always have to look at the directions because things may not be exactly as they appear. So on my little triangle, I'm going to put an 8. On the 7th grade math chart, for formula to find area of a triangle, let's see, what does it say, guys? Thanks for helping me, I appreciate that. Half BH. Okay, think back to the rectangle. The rectangle said BH. The triangle has BH. The only difference is this little fraction of half. So after we do base times height on triangle, we're just going to divide it by 2 and take half of it. The numbers for the triangle were 5 and 8. So 5 times 8 is 40. And then remember it says you need to take half of it. So 40 divided by 2 is 20. Then the final step would be, let's add it all together to get the total. So if I take the rectangle and I add it with the triangle, 30 plus 20 is 50. So I have 50, the units are centimeters, and I'm going to put the little 2 exponent for squared. 50 square centimeters would fill up the space. Okay, we have another diagram, and this one for people who like basketball, this actually could be the lane of the basketball court, and this would be the area above the free throw line up to the top of the key or the 3-point area. So let's say maybe we were going to paint all this space a certain shade, and we need to know how much total area it's going to be. I could separate it into my 2 shapes just like before. I could have the bottom part, which looks like a rectangle or a square, and then the top portion looks like this. It's not a full circle, it's half of a circle. So I'm going to write that down let me put it down here. We have half of a circle, and that says shape 1 again, but it should say shape 2 right here. Okay? So we have half a circle and we have a rectangle. We have been doing rectangles forever, since like the beginning of time in the dinosaur age. So again, rectangles on 7th grade math chart says BH, base times height. Let's go back to the diagram and see what are the numbers on the rectangle. We have 14 as the base and 10 as the height. So 10 and 14. Those are our dimensions. The formula says just multiply them. 10 times 14. 10 times any number is just write down the number and add a 0 to it. So 10 times 14 is 140. Then we want half of a circle. So this one, people may need to look back and check their math charts. Alright guys, help me out here. Area of a circle. I know it's going to have pi in it because all the formulas with circles have pi. Wait for it, wait for it. Oh yeah, awesome. Okay, r with an exponent of 2. I sometimes don't like using the exponent of 2 because people get confused and they just do 2 times the radius. But we know that that little exponent means multiply the radius times itself. So when I set this question up, I'm going to say pi times radius times radius. The problem is when I look back in my diagram, I don't really see just a radius. I see that this number is 14 and it goes all the way across the circle. So if I label all the way across the circle as 14, but my formula says all I need is radius, then how far should we really just measure? Okay, half of 14 is 7. Let's take that number 7 now that we figured out the radius is, and let's put it into this little formula so we can just multiply and be done. Pi is 3.14 times, we just got through finding out that the radius we need is 7. I'm going to put in the 7 times 7. I'm going to go ahead and do 7 times 7 part of this multiply problem because I know that one. 7 times 7 is 49. And then I would need to multiply that by 3.14. I am really running out of space, but I did this on my handy dandy calculator. And 49 times 3.14 is, I'm going to just tell you and we can write it down. 153.86. So let's regroup here. The shape we just did was half of a circle. The formula that we use is for a full circle. Okay? 153.86. That is a full circle, but we only need half. So, how do you guys find half of something? Awesome. Thank you so much. You should divide by 2. Alright, so now we just need to half the quantity we got for the circle right here, 153.86. We just need to divide it by 2. I have no idea what that is, so I definitely need to divide it out. 153.86 divided by 2. We'll save some time and I'll just tell you. Let me type it in on my calculator. Alright, half of that is 76.93. So the semicircle, that's a math term for half a circle, semicircle is 76.93. And the rectangle we said was 140. We're going to add those together. And the total that you get, I'll put it up here so you can see, 140 plus 76.93. And 140 was a whole number, so if you like to put a decimal and add in some zeros, that's awesome, because when you add, you do need to line those decimals up. 6 plus 0 is 6, 4 plus 7 is 11, and 1 plus 1 is 2. So in this one, my final answer, I have 216.93, and I need to make sure I go back and put in the units. This diagram was measured in millimeters, so I'm going to put millimeters, and that last final thing to show you're doing area is the little 2 exponent for squared. 216.93 millimeters squared. When you guys are doing any questions on your own, remember these things. When you get a composite figure, the best way to find the area of it is to split it into smaller pieces that you can find the area of. And 7th graders, this is our math chart. This is the section called area. You can find all the formulas that you need to find the shapes on your assignment.